the last example for a boundary value problem. Well, we're going to be seeing a lot. It's not like it's going to end. We're going to be seeing a lot more of this later on. We have to do this all over again for every PDE that we solve. And just think, we're not even at Fourier series yet. Imagine how long these problems get. This is good practice. This gets us in tune, gets us ready to do solve PDEs as fast as we possibly can. So let's go ahead. Now using repetition from the last... Oh, they changed it on us. Look at that. There's negative now. Yeah, look at that. That almost got me, to be honest. Good thing I saw that. Okay, yeah, they changed it on us. Isn't that funny? Alright, well, let's do this case here. You know what? It's always better to work our way up, you know what I'm saying? So let's do this. Lambda equals negative mu squared. Oh, this one's gonna be non-trivial. See, I remember I'm learning the pattern here. Because this is negative, this is gonna be non-trivial now. I think. Yeah, it definitely will be, because this is gonna be complex. Because look, that becomes negative, it's positive, you move it over, it's negative. Solve the characteristic. Yeah. This is going to be non-trivial. So we picked the non-trivial one first this time. That's the first. Usually it's the last one. So I'm just writing out the general solution for complex roots. No e terms because the real part is 0. Now let's take a look at the first thing here. So we have y of 0 equals 0. Sine, yeah, so we're just left with c1 equals 0, right? Cosine of 0 is 0. So a cosine of 0 is 1. I haven't seen one of these in a while. This one would be... Right, that's what we're left with. And then we also have... now, I'm going to be honest with you. This is going to be a very short example because I see, because we're going to use our knowledge that we've learned over the last 5 examples to do this one. So we get to here. We do the second one. Oh, wait a minute. No. Nope. We're good. This be cosine. As you can see from this one here, mu can be 0. However, that is non-trivial. So now let's look at this one over here. Mu of x has to be... this is the n minus 1/2 times pi. Wait, I was supposed to plug in L for x there. It's gonna say, okay. And I'm gonna rewrite this as 2n minus 1 over 2, so then that's over 2L. Right. And I can tell you right now, we can just stop there. That's the whole problem. Because if, for this problem, when this is equal to 0, we're going to have, once again, this doesn't change because of the negative. This is still the same. We're going to end up with right, and then we'll get this moves to this, and then right. You can see that's only trivial, and then for this one over here, we're gonna have this is the other case where it's like this. This is the only one that's not left, and we have we have one non-derivative, so that ends up being something like remember they always looked like this. We just plug in, because then we plug in 0. Oh, we plug in 0, so then we end up with this. In all the cases when we had this, we rewrite y, and then we end up taking out the, we end up with something like this. Remember this? So then this, if mu is 0, then this becomes 0. So mu is 0. If mu is 0, well, I didn't rewrite the thing here, but this would become, sorry, this is kind of crammed, but minus C2 plus C2 0, so that's trivial. This is trivial. Oh, hold on. No. Yeah, this is trivial. So this is the only non-trivial. This is trivial over here. I'm so tired of getting things mixed up. So this is the only one we have that we like. Right? Only one. Okay. So our eigenvalue is that was for when it was less than 0. Okay. Oh yeah, it's less than 0 now. So this is going to be a little different, I guess. The whole thing is just going to be negative. I'm going to write it like this. Oh man. You know what? Let's do it. Let's write it like this. That's kind of ugly, isn't it? Yeah, that's kind of ugly, yeah. Yeah, there's different ways of writing it and whatnot, but it is correct what's there. How did I write it in my notes? Let's take a look. Okay, I wrote it like this actually. Which, sure, makes sense. Okay, this would be what we left with sine mu x. Alright, okay. Times x, so we can put that on top. And there's the answer. Okay, that should be it. That is it for boundary value problems. So now we can see we solved for y sub n. The next point will be solving the other ODE that we didn't solve for. Like if you think about the heat equation overview again, we solved for x sub n, but then we also had t that we didn't solve for, so we have to solve for t sub n next, which the eigenvalue will come in handy for. So that will be the next video. That should be short. That should be a short and easy video to do. All right. So I'll see you then. Hope you enjoyed the video.